Okay, so we're going to talk about vertical asymptotes and wholes. And so any x value that is not in the domain of a rational function is a whole or a vertical asymptote. So they occur where the function is undefined or where you're going to get 0 in the denominator, basically. So the last lesson we learned about finding the domain. So today we're going to figure out if those things that are in the domain are wholes or vertical asymptotes. All right, so a vertical asymptote is going to come from the 0 of the denominator. I guess the rows that are not in common with the numerator. Or another way to say that is outside the box. In the denominator, outside the box. All right, and then wholes are going to be the zeros of the denominator. That are in common with the numerator. Or inside the box. Now the vertical asymptote we're just going to give as x equals a number. That's the equation of a vertical line. But the whole we're going to give as an ordered pair. And so I'll talk about how to find the y part of the whole. So what's inside the box is going to give you the x part of the whole, and then we'll have to do something extra to get the y. Okay, so just like yesterday, the first thing we're going to do is start off by factoring the numerator and denominator. So you guys go ahead on number 1 and factor that for me, please. Okay, so do you guys see anything we need to box up?
Yes.
Yeah, good job. Whatever they have in common in the numerator and denominator, we're going to box it up. Okay, and then we're going to find the vertical asymptote, and that's going to be in the denominator, outside the box. And we're still using the opposite like we did on the previous lesson. So what do you think the vertical asymptote is going to be? X equals 1. Good job. All right, and then for B, we're going to find any wholes. And so that's just going to be inside the box. That's going to be the x part of the whole. So that's going to be the -4. All right, now we can't just put -4 back in to the function because you would get 0 over 0, which is an indeterminate value. And so what we're going to do is we're going to put it in to the parts of it that are not inside the box. All right, so it's kind of like a reduced version of the function. So we're going to put it in the numerator, and so we'll get -4 minus 4, and then -4 minus 1 in the denominator. It's a hard thing to articulate that without using some mathematical concepts that you don't know about yet. Anyway, we get -8 over -5, which is going to reduce to 8/5. That's where you would have to draw a little bit hole in the graph. That's it. That's the new stuff. It's not too bad. All right, we're going to do another one. It's already factored. So do you see anything we need to box up? No. So if you don't box anything up, what do you think that means about the holes in the graph? Right. So I'm just going to go ahead and say none for holes. There's not going to be any holes. All right. What do you guys think about the vertical asymptotes? Is there one? Yeah. Yeah. X is -3 is going to be your vertical asymptote. All right. And then this last one, we're going to do all the things. So hopefully you're going to remember it all. I'll remind you though if you don't. All right. So start off by factoring it. So you guys can do that on your own. Okay, I'm going to go ahead and box up my x minus 6. Okay, so there's two things that x cannot be because that's going to give you 0 in the denominator. What are they? Very good. 6 and -6. So that means that we're going to either have a whole or a vertical asymptote at 6 and -6. So we're going to figure out which is which in just a second. All right, and then from a previous lesson, we're going to find the x-intercept and we're going to find the y-intercept. So the x, you guys remember where we look to find the x? Numerator, inside the box or outside? Outside. Good job. All right, so our x-intercept is going to be when x is -4. Now, some of you did the x-intercept as an ordered pair. I love that, actually. It would be -4, 0 if you want to write it that way. All right, what about the y-intercepts? Right. Find f is 0. So inside the box is going to be the whole. So the y-intercept, we're going to make everything 0. We're going to get -24 over -6 originally. So what's the biggest thing that goes into 24 and 36? It's bigger than 6. 12. So that's going to be 2/3. All right. Is this graph going to have a hole? Yes. So it's going to come from inside. So what's the x going to be? 6. Good. All right. And then to get the y, we're going to take that 6 and we're going to put it into the parts that are outside the box. Good job. Now, a lot of times the y part of the whole is at some weird fraction, so don't worry. It's not a big deal. It's just how these problems work out. Right. Is this graph going to have a vertical asymptote? Yes. So we're in the denominator, outside of the box. What's my vertical asymptote? -6. So 6 was the whole. -6 is the vertical asymptote. Now, I could have figured that out without even looking at my function. I could have just looked here. So I know that if my whole was at 6, then this other one had to be my vertical asymptote. Now, you can have 2 holes or you can have 2 vertical asymptotes, but if it's not in the domain, it's one of those 2 things. All right, is this one going to have a horizontal asymptote? Maybe. So remember, we were looking at the degrees when we're figuring out. So this is the first thing we learned, and it's probably the most difficult one to remember. So that's why we're doing it every day. So what do you notice about the degrees? They're equal, so same degrees. It's not zero. It's zero when the numerator is less than the denominator. So when they're the same, we have to do a little fraction. So what do we do? Right, leading coefficient over leading coefficient. So that's 1 over 1, or just 1 for your horizontal asymptote.